Hello, math learners! Today, let us have more applications of logarithmic functions. The learning objectives are: you are going to apply exponential and logarithmic properties in simplifying expressions and equations, and solve real-life problems involving exponential and logarithmic functions. Exponential and logarithmic functions are used to model a wide variety of behaviors in the real world. The applications are drawn from many different disciplines. Some examples here include level of sound, investments, population growth, and chemistry, like the pH balance, which is a measure of acidity and alkalinity. Let us have problem number 1 about the population growth. The population P of a city increases according to the formula A is equal to PE raised to RT. In 1980, the population of a city was 5,000. In 1990, the population became 10,000. Find the rate of increase. Let us recall first the exponential growth formula, which is A is equal to PE raised to RT, wherein A is the estimated population after T years, P is the initial population, E is the constant, which is the base E, equivalent to 2.718281828, and R is the rate, and T is equal to the number of years. Let us have the solutions. Given A is equal to 10,000, P 5,000, T 10 years, that is 1990 minus 1980. First, you have to use the formula. So we have A is equal to PE raised to RT. And then substitute the values. We have 10,000 is equal to 5,000 E raised to R times 10. Then simplify the exponent part, you have 10R. Then we need to use the symmetric property, just interchange. So we have now 5,000 E raised to 10R is equal to 10,000. And then we have to divide both sides by 5,000. What we have is E raised to 10R is equal to 10,000 over 5,000. Reduce this, so you will have 2. Then you have to express this in ln form because the base is E. So we have ln2 is equal to 10R. And then we have to solve for R. So R is equal to ln2 over 10. So just divide both sides by 10. And take the value of R in decimal, so that is equivalent to 0.06931471,806. And transform in percent form. So what we have is 6.9%. You can move 2 decimal places to the right from here, 1, 2, and then round off. So the answer, the rate of increase is 0.069 or 6.9% of the population from 1980 to 1990. Next, let us have problem 2, still under population growth. In the year 2000, the population represented by P sub 1 is equal to 10,000. And in the year 2020, the population represented by P sub 2 is 20,000. The population of two cities are defined by the formulas A sub 1 is equal to P sub 1 E raised to RT, and A sub 2 is equal to P sub 2 times E raised to 0.01 T. Find the constant R so that the two populations are equal in the year 2020. So let us have this first. Using the exponential growth formula, and this is the standard form, if A sub 1 is equal to P sub 1 times E raised to RT, and A sub 2 is equal to P sub 2 times E raised to RT, then A sub 1 is equal to, replace P sub 1 by 10,000, then copy E raised to RT, and A sub 2 is equal to 20,000 times E, and then R is equivalent to 0.01. So it's given here, times T. If A sub 1 is equal to A sub 2 when T is equal to 20 years, then P sub 1 times E raised to RT is equal to P sub 2 times E raised to RT when T is also 20. Then, we have this equation, P sub 1 times E raised to RT is equal to P sub 2 times E raised to RT. Let us have the solutions of problem number 2. Given P sub 1 is equal to 10,000, P sub 2 is equal to 20,000, and T is 20, we have to use the equation, which is the P sub 1 E raised to RT is equal to P sub 2 E raised to RT. Then substitute the given, we have now 10,000 E raised to 20R is equal to 20,000 E raised to 20 times 0.01. This is given in the problem. And then you have to divide both sides by 20,000 E raised to 20R. So this is now the form. Divide by 20,000 E raised to 20R. And then simplify using the quotient rule. So you will have this portion is equivalent to 1/2. The exponent here is equivalent to 0.2. And then, using the quotient rule, you will have E raised to 0.2 minus 20R. And then, you have to express in ln form. So you have ln 1/2 is equal to 0.2 minus 20R. And solve for R, transpose 20R here, it becomes 20R. Transpose ln 1/2 here, so it becomes negative ln 1/2. And take the value of ln 1/2, which is negative 0.6931471806. And then simplify this part. This is equivalent to 0.8931471806. So divide by 20. R is equal to 0.044655735903. Or you can run off into 0.04. This is not the value of R. So the answer is 0.04. Let us have problem 3. Periodic growth. How many years will it take an investment of 25,000 pesos to double in value if interest is compounded quarterly at a rate of 10%? Let us have first the periodic compounding formula, which is A is equal to P P times the quantity 1 plus R over N raised to NT, where A is the accrued or owed amount or the compound amount. P is the principal invested. R is the annual rate of interest. N is the number of compounding periods or conversion period per year. And T is the number of years. Let us have the solutions. Given P equivalent to 25,000 pesos, R is 10% or 0.10, N is 4 because this is compounded quarterly. And A is 50,000 because you multiply 25,000 by 2 because you will double the value. You have to use the formula and then substitute the given. So A now is 50,000 is equal to P, which is 25,000. R is 0.10 over 4 raised to 40. And you have to divide by 25,000 both sides. So this is now the form. And simplify. 50,000 divided by 25,000 is 2. 25 over 25 is 1. And 0.10 over 4 is 0.025 raised to 40. And simplify. This is equivalent to 1.0.25 raised to 40. And take the log of both sides. So we have the log of 2 and the log of this expression. And then you can use the power rule. Just simply write 40 here before log. Then divide by 4 log 1.025 both sides of the equation. So this is now the form. And then you can cancel 4 with 4 and log 1.025 with log 1.025. So what is left is T. And then just apply symmetric property. Interchange the position. So this is now the form. Solve for T by taking the values of log 2. This is the value. And then 4 log times 1.025. This is the value. So T is equivalent to 7.021775861 or approximately 7 years. So the investment will double in value in approximately 7 years. Next, problem 4. The spread of a virus through a city is modeled by a function N is equal to 15,000 over 1 plus 100 e raised to negative 0.5t, where N is the number of people infected by a virus after T days. How many days it takes for 2,000 people of this city to be infected with the virus. Let us have first a little information about the virus. A virus is an infected microscopic parasite much smaller than bacteria and able to multiply only within the living cells of a host. When a virus is completely assembled and capable of infection, it is known as a variant. Viruses stack both inside the host cell and within the host itself by creating conditions that allow for them to spread. Viruses cause many common human infections and are also responsible for the number of rare diseases. The variants spread exponentially, like the outbreak of coronavirus, which we call the COVID-19. With exponential growth, the number of new cases each day constantly increases. That is why we are asked to stay at home, stay safe, and wear our mask. And one of the formulas used in this kind of problem is N is equal to 15,000 over 1 plus 100 e raised to negative 0.5t. T, where N is the number of persons and T the number of days. Let us have now the solution. Given N is equal to 2,000, we have to use the formula, this formula, and substitute 2,000 to N, and then we can cross multiply. We have now 2,000 times 1 plus 100e raised to negative 0.5t is equal to 15,000. Then simplify by dividing both sides by 2,000. Then we have 1 plus 100e raised to negative 0.5t is equal to 15,000 over 2,000. Then you can transpose 1 to this side. You can simplify this part. So we have now 7.5 minus 1 and divide both sides by 100. So what we have is e raised to negative 0.5t is equal to 6.5 over 100. And convert in ln form. This is the exponential form. So the ln form is negative 0.5t is equal to ln times the quantity 6.5 over 100. Then solve for t. So t is equal to ln 0.065, the result of this, over negative 0.5 because you will divide both sides by negative 0.5, and the result is 5.467, or t is equal to 5.5 days. So this is the number of days, and it will mean that it will take 5.5 days for 2,000 people to be infected with the virus. Next, let us have a problem about sound measurement. The level of sound D in decibels is defined as follows. D is equal to 10 log times the quantity I over 10 raised to negative 16, where I is the sound intensity in watts per centimeter squared. Determine the level in decibels of a sound with intensity I is equal to 10 raised to negative 8 watts per cm squared. This is how decibel meter looks like. This one. So, let us have information first. Decibel is usually a way to measure the volume or the loudness of a sound. Decibels are a base 10 logarithmic unit, which means that increasing a sound by 10 decibels results in a sound that is twice as loud as the base sound. In general terms, a sound's decibel value is given by the formula D is equal to 10 log times the quantity I over 10 raised to negative 16, where I is equal to sound's intensity in watts per square units. The decibel unit is dB, is a logarithmic unit used to measure sound level. Let us have now the solutions. Given I is equal to 10 raised to negative 8 watts per cm squared, first, we have to use the formula. So this is the formula. And then substitute the value of I. So the value of I is 10 to the negative 8. And then we apply the laws of exponents. We can simplify the negative exponents into 10 raised to 16 over 10 raised to 8. And the result of this is 10 raised to 8. Then we can use the power rule by multiplying this expression with the exponent 8. And then simplify 10 times 8, that is 8. Log of 10 is 1. So 80 times 1 is 80. So the level of a sound with intensity I is equal to 10 raised to negative 8 watts cm squared is 80 dB or 80 decibels. Let us have problem number 6, still on sound measurements. Two sound of intensities, I sub 1 and I sub 2, have decibel levels of 60 and 80 respectively. Use the formula for decibel level given in problem 5 to determine the ratio of intensities I sub 2 over I sub 1. The intensity of a sound in decibels in dB units is defined by the formula D is equal to 10 log times the quantity I over 10 raised to negative 16, where I represents the sound's intensity in watts per square units. This logarithmic scale is called the decibel scale, or the sound level meter is a specialized tool which uses a sensitive microphone to measure the amount of noise in the environment and give you a precise decibel value. So, this is how decibel scale looks like. Let us have the solutions. Given I sub 1 is equal to 60 dB and I sub 2 is equal to 80 dB. Use the formulas in problem 5. So we have 80 is equal to 10 log times the quantity I sub 2 over 10 raised to negative 16, and 60 is equal to 10 log times the quantity I sub 1 over 10 raised to negative 16. And you have to subtract side by side. This is now the form 80 minus 60, then 10 log times the quantity I sub 2 over 10 to the negative 16 minus 10 log times the quantity I sub 1 over 10 raised to negative 16. And then 80 minus 60 is 20. Then copy. Divide both sides by 10. So you will divide this by 10. This becomes 2 and this one is 1. And use the logarithmic property. So you will have 2 is equal to log times the quantity I sub 2 over 10 raised to negative 16 all over I sub 1 over 10 raised to negative 16. So this is the expanded form of the quotient rule, and this is the condensed form or the single form. You can simplify this expression into this form and cancel 10 to the negative 16 with 10 to the negative 16. So what we have is 2 is equal to log times I sub 2 over I sub 1. Then we can express this in exponential form wherein the base is 10. Then what we have is 10 squared is equal to I sub 2 over I sub 1. And then you can take the square of 10, which is 100. So the ratio of the two intensities is 100. So the answer is 100. Let us have problem 7 about acids and bases. A tomato has a pH of H plus equivalent to 1 times 10 raised to negative 4. What is the pH level of a tomato? Let us have some information first. Acid is a substance whose water solution tastes sour, turns blue litmus red, and neutralizes bases. Base is a substance wherein its aqueous solution tastes bitter, turns red litmus blue, or neutralizes acids. Salt is a neutral substance whose aqueous solution does not affect litmus. Litmus paper is a paper that has been treated for pH indicator. Aqueous solution is one in which the solvent is liquid water. The pH scale was developed to express the concentration of hydrogen ion in solutions and is used in discussing acids and bases. pH was defined as the negative log of the hydrogen concentration and defined by the formula pH is equal to negative log H plus, where pH is equal to the measure of hydrogen ion concentration, and H plus represents hydrogen ion. Let us have now the solutions. Using the formula pH is equal to negative log times H plus, substitute the value of H plus, so you have 1 times 10 raised to negative 4, and express 1 into 10 to the 0 exponent. So instead of writing 1, you can write this in 10 raised to 0 exponent. Then use the product law of exponent, simplifying these exponential expressions. Then we have 10 raised to negative 4. Then you can evaluate the log of this, which will result to negative 4. Then you can express pH equals to negative 4 into pH is equal to negative times negative 4, this one. So the result is 4. Therefore, the answer pH of H plus is equal to 1 times 10 raised to negative 4 is 4, which is an acidic solution. Take note, the pH can be expressed as pH is equal to negative times negative 4, which is just equivalent to 4. Next, let us have problem 8. Still on acids and bases. What is the pOH H plus is equal to 1 times 10 raised to negative 4. Take note, the pOH scale is similar to the pH scale. The pOH is convenient to use when finding the hydroxide ion concentration from a solution with a known pH. So acids and bases react with one another to yield two products, water and a unique compound known as salt. This kind of reaction is called a neutralization reaction. You can have this in your chemistry. And then the water equilibrium constant is defined as 14 is equal to pH plus pOH, wherein pOH is the measure of hydroxide ion concentration equivalent to OH negative. Alkaline is any substance having a base pH higher than 7. And this is the pH scale. So, if you have vinegar, the pH is 3. Water is 7. That is only neutral. And for the bleach, that is 13. Under alkaline. So, for the solutions, in problem 7, the pH is equal to 4. So, we have to use the formula. 14 is equal to pH plus pOH. Then substitute 4 to pH, change pH to 4, then transpose 4 to the other side. We have negative 4, and combine. Then what we have is 10 is equal to pOH. Then apply the symmetric property, just interchange. So you have pOH is equal to 10. So therefore, the pOH of H plus is equal to 1 times 10 to the negative 4 is 10, which is an alkaline solution. Do you have questions? If there is none, then see you next time. Bye!